Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Coding 101 is provided by CacheFly at CacheFly.com.
Coding 101 is brought to you by Lynda.com, the online learning platform with over 3,000 on-demand video courses to help you strengthen your business, technology, and creative skills. For a free 10-day trial, visit lynda.com/C101. That's lynda.com/C101. And by DigitalOcean, simple and fast cloud hosting built for developers. Deploy an SSD cloud server in 55 seconds. Try it today for free. Visit DigitalOcean.com, and once you sign up, be sure to enter the promo code C101 in the billing section for a $10 credit. Today on Coding 101, we bring you another wildcard episode. We're talking to Peggy Fisher. Hello and welcome to Coding 101. It's the show where we let you into the wonderful world of the Code Warrior and the Code Monkey. I'm Father Robert Ballecer, the Digital Jesuit, and joining me as always is my super special permanent co-host, Mr. Lou Maresca. Lou, I just can't give up the really cool title. We're just going to have to change that every episode. How are you doing?
Doing well. Thanks for having me back. Keep changing it every episode. We'll get there soon.
We'll get there. So it says Code Warrior right now, but at some point that title is going to change to Permanent Super Special Geeky Co-host. But we'll worry about that later. Now, Lou, this is a special episode for us. We do like to stop in between of our modules. So we were just talking a little bit about Swift. We were talking before that a little bit about Ruby. We like to clear the palette, as it were, between programmers, between programming modules, by speaking with programmers who we find particularly inspiring or their stories compelling. And so we bring on to the show Miss Peggy Fisher. Peggy, thank you very much for joining us on Coding 101.
Oh, you're welcome, Father. No problem. I'm happy to be here.
I should say, Peggy does do work for Lynda.com. Let's get that disclaimer out of the way. But I actually reached out to them. I've been trying to get a few of the programmers that Lynda.com has in their stable onto Coding 101, and we were always worried a little bit about conflict of interest, but eventually it came down to, no, this is a person who has a great story that I think our audience will like, and they agreed. So thank you very much for coming onto the show.
No problem.
Let me ask you this. You have a very interesting backstory of how you got to where you are today. I don't want to spoil too much of it. I do want to let you get the narrative out there. But you did start off programming for an insurance company.
When I went to school for my undergrad, I actually majored in computer science. And when I graduated, I got a job at an insurance company, at Prudential Insurance, and I was hired on as a programmer. And I programmed in COBOL. And it's kind of interesting now, because later in my life, now I teach programming, and I don't think any of my students know what COBOL is. But COBOL is a mainframe programming language. And that's where I started my career and learned a little bit about CICS along the way. That's what you would call the GUI of COBOL. The CICS is the front-end portion of the big mainframe systems. So that was the start of my career.
COBOL, that brings me back way, way, way back. Let's take a step back before that. What got you into computers in the first place?
You know, it's really interesting. I think I just was at the right place at the right time. My senior year in high school, they actually got their first computer. And so this is back in, I hate to say this because you're going to know how old I am, but this is back in 1979, the school year of 79-80. I graduated in 1980. And so they got their first computer, and it only took tapes. But we got a chance to actually use it because I really, really loved math. I thought math was fun, especially algebra. And so my love for math got me into a class that allowed me to take a little bit of computer also. And so when I was trying to decide what to do in college, I'm like, well, I really love math. I really like programming. I thought that was fun. And so I decided to go for programming. I wanted to be a math teacher at one point, but when I kind of weighed computer science and the money I'll earn and teaching math and the money I'll earn, I went for computer science as an undergrad. So that's how I got there. I was very fortunate that I was at the right place at high school in the right time to take that step forward.
You know, Peggy, it's interesting because one of the themes that we've had running on this show is we've had master programmers who tell us that you can't just decide that you want to be a programmer for the money. It doesn't work that way.
Right.
What's interesting about your story is you got into the computers and then you had to decide, well, do I do it out of my passion, or do I do it because I need to make the money? And
Right.
that's a different kind of decision.
Yeah.
Let me jump off the rails really early, just so people don't think we're actually going to stay on the path we intended for the show. You use reel-to-reel tapes. I was also of a generation that had reel-to-reel. I actually still had a couple of computers that used punch cards.
Oh, I was going to say, yeah, I used that in college.
But that whole era was a time when we didn't really know what discipline this new computer science, this new computer technology fit into. Some said it was all mathematics. Some said it belonged with the engineering disciplines, and it belonged someplace else. That's really when this whole idea of computer science started to shape up and become its own thing. Were you caught up in a lot of that?
You know, I think I was lucky enough that a lot of that was already decided. Because when I went to, like I said, for undergrad for computer science, it was pretty much set up. It was more technical, though. Like today, I think there's a whole nother branch of like information science and technology that is more what I learned. But today, computer science, I think, is a lot more architecture type of information, like getting down all the way down to assembly language, where I think there's like two phases. Either you're like a business programmer or you're a technical programmer. But I think I skipped the kind of in between that you're talking about.
Yeah. And COBOL, I did not like COBOL at all.
It's very wordy.
What was it like to Did you program in COBOL for 18 years?
No,
Okay.
no. I started out as a programmer, and then I worked my way to a systems analyst, and then to a manager, and actually after my 18 years, I was actually one of the directors at Prudential, so I was in more of a management role at that time. But I did like COBOL programming. It's funny. It's a different beast. Definitely. It's very linear. It's not object oriented. It's very sequential. But at the time, it was pretty much the only thing. And it was just, for me, it was the really cool thing of whether I had punch cards or typed it into the computer, taking it to the computer room, having them run it, and then see the results. Like that whole idea of, hey, I did this, I made this happen. I made this report come out. And problem solving. I love to solve problems. I love to do puzzles. And to me, programming is like a giant puzzle that you're just trying to solve.
All right. Let's talk about that programming as a giant puzzle, because we had Steve Gibson on a while back, and he was talking about foundational knowledge. And it was the whole thing of, well, what brings you in to a computer science discipline? What brings you into an engineering discipline? And especially, what brings you into a mathematics discipline? And it has to be an underlying desire to figure out puzzles. You have to love puzzles. And they have to be ultimately rewarding to you. Otherwise, you lose interest very quickly in the discipline.
Yes. Yeah, I totally agree with that. I've always been kind of like a puzzle or problem solver. Like that's the thing. That's my strongest skill, I think, is, I really believe that when I learned COBOL, since that time, I've never formally been taught any language. But since I had that COBOL experience, and I know how to solve the problem of how do I read from a file, how do I calculate the data, and then make the output happen, those skills have allowed me to learn. So at this point, I feel comfortable with C, C++, C#, XNA, HTML, JavaScript, Java. Python, I've just recently learned. So I think that those skills are transferable to any other programming language that I've encountered so far. And it's like you said, so the puzzle there is, okay, I'm going from Java to C++. My puzzle is, what syntax does C++ have that's different than what Java had to do the same thing? Because ultimately, you know, we want to be able to process data. We want to be able to interact with the computer. But what language it is doesn't really matter, and it's kind of a puzzle to figure out, okay, here's my language. How can I make it work?
That was one of the puzzle pieces that we had to deal with when we put together Coding 101 in the first place, because people wanted to know, well, what language are you going to program in? And I said, well, I want to program in all of them. I want to have all the languages as part of the show.
Absolutely,
and they didn't get it. They said, well, how can you teach programming in 4-week chunks? But as you said, so much of that knowledge transfers over. And once people watch 1 module, 2 module, 5 modules, they start to say, oh, I get it. It's just the language. The logic behind it stays the same.
Exactly. That's, you know, I try and tell people that, you know, once you get the logical thinking down and you understand basically that these computers are, I always tell my students that they're really dumb and they're going to do whatever you tell them to do. And you got to tell them the right steps to be able to figure out the puzzle that you're giving it. And whether you use Java or C++ is not going to matter, but you have to figure out what those steps are first. Yeah.
Yeah. Lou, let me ask you a quick question here. You heard Peggy talk about the languages that she's very comfortable with. Every professional programmer has at least how many? 3, 4 primary languages, and then maybe another 6, 7 languages that you know enough to code around in?
Yeah, I think that Peggy pointed it out. I think it's really dependent on what generation you come in at. I think nowadays the really popular languages are the high-level languages like C# and Java, and even higher than that, browser-level languages, JavaScript. And so, like, learning those things, you tend to learn more about those languages that are used most often and become more of an expert in those languages. And then, maybe you have to go back and do other things in other languages that some projects might require, or you might need to do it, to be at better performance, that kind of thing. And so I think you're right. I think you tend to kind of hone in on one specific or couple specific languages, and then, try to transfer. Peggy, I actually had a question on that. Do you feel that even your students sometimes struggle where they do learn about logic and how to program, but then, when they need to transfer to a different language, it's really kind of like the ramp up, the onboarding of that language, like learning the different tool sets and the new GUIs and how to get things compiled and all that stuff? Do you think that that's really the challenging part when you move into different languages?
Yeah, you got it, Lou. I mean, that's exactly it. You go from, let's say, a C# to a Java. The GUI, if you're going to do GUI, it is drastically different. And you need to know, okay, well, in Java, first of all, what IDE am I going to use, integrated development environment? And then from there, what tools does that IDE have for me to do a GUI in Java? But yeah, you're right. Sometimes the APIs and understanding what an API is, you don't use it that too much in C# as much as you do in a Java program, and so getting them to understand that as well. So I think you have a valid point there. Yeah.
Peggy, let me ask you a little bit about this. So, again, let's go back to that 18 years that you spent programming for an insurance company. Eventually, you ended up as the director of information technology. One of the members of our chat room, I think it was Vince360, he jokingly said, well, I'm into programming for the glory, which anyone who's been programming knows there is no glory.
What glory?
No longer. There may have been a time at the very early stages where you could have a programmer who said, I wrote this, I created this. But it's been decades since that's been the case. You're always working with somebody else. You're always iterating someone else's work. And so even though he was joking, that's one of those warnings that we try to give students, which is, again, it's got to be about the passion, because if you think you're going to get famous doing this, no. Just no.
No, you're so right. I've known several people that have continued in the programming field, but you do have a ceiling there, and it's not, they don't look at you and say, "Ooh, there's Lou, super programmer." Yeah, it definitely is. like you said, you have to have the passion for it, and if you do and you want to keep doing it, that's great. My passion, I think, the way that I satisfy it is by learning new languages. Because I think if I, like you said earlier, if I had to stick with COBOL up to this point, so now I've been in the in the working field for about 30 years. I don't know that I would have wanted to stick with COBOL for 30 years. So my passion is still programming, but it turned into teaching programming as well.
We're going to be speaking with Peggy a little bit about that passion, that transition of passion in just a bit. But before we get to that, and Peggy, let's tease them a little bit. After these 18 years, after getting that director of IT, that position that a lot of our audience would love to have, you decided to throw it all away. Well, not necessarily throw it all, but you decided to walk away from it to do something that you were more passionate about, which is, again, that's one of the reasons why I wanted you as a guest, because it is something I just respect so much. But before we talk about that, let's go ahead and thank the first sponsor of this episode of Coding 101. Now, folks, let's be honest. If you want to know something, and it doesn't have to be programming. It could be about business software. It could be about business skills. It could be about your latest, greatest hobby. You need to go to a place that teaches you the things that you want to learn at the pace that you want to learn them. Well, you could jump from site to site and person to person, and there's plenty of good outlets for knowledge on the internet. Or you could go to the place that I go to, the one-stop shop, the repository of knowledge, lynda.com. Now, lynda.com isn't just about taking all that knowledge and putting it together in one place. They've actually put the grunt work into making sure that they offer you the material in a way that is most beneficial to your learning. They understand that you need to work at your own pace. They understand that you need to take the courses that you want to take. They understand that they should use proper lighting and camera work and audio work so that that doesn't distract from the lesson at hand. Now, lynda.com is for problem solvers. It's for the curious, for the people who want to make things happen. Maybe you want to learn a new programming language, take better photos, master Excel, or sharpen your HTML skills. Well, Lynda has the course that you need, that your curious mind longs for. Now, some of the new lynda.com courses that I recommend are PHP with MySQL, Essential Training, NoSQL for SQL professionals, CSS, selectors and developing Android apps, Essential Training. Lynda.com also has great courses on programming iOS apps and the Swift programming language if you want the latest and greatest from Apple. Now, we've been using lynda.com courses here on several different occasions. I use it when I'm trying to develop new programs for know-how, when I want to show people how to do professional photography. We use it here in the studio because we've switched over from the Mac and Final Cut Pro to the PC with Premiere. And, well, we just needed a reference that we could go to, which is one of the things I like so much about Lynda. They offer you transcripts of all the courses, so you don't have to sit through an entire module. You could find the piece of video that has the answer to your question and go straight there. Now, with lynda.com, you can watch and learn from top experts, people like Peggy, who are passionate about teaching. You can stream thousands of video courses on demand and learn on your own schedule. You could learn at that pace that your brain needs to absorb the information. And, like I said, you can browse their transcripts, take notes as you go, and refer to them later. You could even make a playlist so you could set up a queue for your knowledge and maybe even share it with your friends. You can create and create tutorials that you will be using on your own personal time. Take them offline onto your iOS or your Android device so you can learn in your free time, maybe in your downtime between meetings or at the office. Now, your lynda.com membership gives you unlimited access to training on hundreds of topics, and I can't recommend it enough. It's all for one low flat rate, and it's so easy to get started. Whether you're looking to become an expert or you're passionate about a hobby, or if you just want to learn something new, because I know you do because you're watching Coding 101, I want you to visit lynda.com/C101 and sign up for your free 10-day trial. That's lynda.com/C101. And we thank Lynda for their support of Coding 101. Peggy, let's get back to you. So, you've got this career that you've been developing for almost 2 decades. You are near the top of your field. You become the director of IT. And then you say, nope, this is not what I want to do with my life. What was that all about?
It's so funny when we're able to like look back and summarize things like that because it really is kind of like, what did you do? Yeah, well, it was a great field to be in. It's a great company to work for, and as you said, I mean, I worked really hard to get to where I was. But at that point, and a lot of you that are listening, and Father, probably you know this too, that at that point you need to put in 50, 60 hours a week to do a good job in that role. I had just met my husband. We were just starting our life together, and I was having to leave for weeks at a time to stay up in North Jersey to be able to, run some projects that I was working on up there. And I realized that although I really liked it, my quality of life needed a change. But I think really what happened, Father, is that the passion inside me to share my love of programming and my love of math with others. So I had been going back to school to get my master's in math education. And at that point, I had finished it. We moved to a very rural area of Pennsylvania, central Pennsylvania, and I was fortunate enough I spent 1 year as a director of IT for a county, for the Mifflin County, but then right after that, I got a full-time job teaching high school, and I did that for 10 years. So I think it was a matter of passion and quality of life that made me kind of say, all right, I did this. I'm really happy. I'm proud of myself, but now it's time for a change.
That just blows me away. There are a few people I know who have stories like that, and I respect them so much, where they had something that was paying for them. I mean, it was a good living, and they somehow said, this is okay, but it's not what I really want. And as you said, you made that decision at the beginning. Do I go into computer science, or do I stick with my passion to teach mathematics? And you did the computer science thing for 18 years. And at that point, it is so hard to make the switch. I mean, it must have felt incredibly vulnerable for you.
It really did. But I had my faith, and I believed, and things just fell into place, Father. It was really cool. I found the intermediate job, the director of IT, for a year, and then the other thing I want to say too, Father, and I strongly encourage people to have confidence in themselves, because when we moved to Mifflin County, I made a point of introducing myself to the superintendent of the school district and had a meeting with him and just said, I'm new to the area. I really want to teach. And by putting myself out there, whether it was for the teaching at the high school, the teaching at the college, or even the lynda.com, those are all things that, happened because I was willing to take that risk. And I think that first step that you're talking about here, when I went from the 18 years to the Mifflin County, that gave me the strength to try it over and over again, and it's always worked for me. I think, I really encourage people to try it.
Brave, just very brave.
No, thank you.
Let's give a bit more backstory. As you said, you had been earning your master's degree in mathematics, math education.
Yep.
You completed that, and then you started teaching high school.
Yes.
And not too long after that, you started, in 2012, I believe you took a position at Penn State for intro to application programming with Java.
Yes.
How long was this transition period between you being an administrator and then you just feeling comfortable as an instructor?
You mean at the university, or from when I went to the high school first?
Both.
Oh, okay. The transition to the high school was probably the scariest. I was really afraid the kids were going to eat me alive. So I was really, apprehensive. But what I found was that, I just feel like I got to know all the individual students. I learned a little bit about them personally, and I showed that I'm human too. When I made a mistake, I admit it. And the transition to the high school, after the first month or two, I realized this is going to be okay. I can do this. And the kids respected me. I believe they liked me. And I felt really good about what I was teaching. And I had gotten, like I said, my master's in math education, so I felt like I had a good background in how to write the curriculum and how to present the information. But I really was worried about how the kids would accept me. I was older. and I just wasn't sure what it was going to be like.
So Peggy, real quick. So when you say like when you actually taught these students, what kind of ramped them up and got them to program? Got them to kind of pick up programming faster. Was there any patterns that you saw? Was it maybe giving them projects? Like what was your kind of curriculum that you tried to follow to kind of get them ramped up quickly?
Yeah, that's a great question, Lou. When I was teaching programming, in the beginning, I kind of took over somebody else's, and I was doing okay, let's start with chapter 1. I don't know if you noticed this, but every programming book has the history of computers as chapter 1.
That's right.
I'm like, all right, we're not even now I don't even bother with that one. But project-based learning is definitely was the way for me to reach the students. Even today, my first day of school at Penn State, the first day in class, I make them program. They don't know what they're doing. They don't understand what I'm doing, but I make them do, a version of Hello World. And I show them it's not this foreign monster. It's not this thing that's not attainable. You just did it. Even though maybe you didn't understand everything, you did it. You're done. That you programmed a program. And as much as I can do project-based is what I prefer. It's a little hard sometimes because you have to get content across.
Right.
But most of my lesson plans now at the college level, the first 20 minutes might be a little bit of a lesson, but then there's definitely projects that we do together or individually.
I've taught at high school and university level, and maybe you can tell me if my read on this is correct. But when I was teaching high school, if I would walk into a classroom and say, "Good morning, class," they'd say, "Good morning." When I walked into my college class and I said, "Good morning," they wrote it down. And that was pretty much, that was the difference between a high school student and a university student.
Oh, that's great. Yeah, that's funny. I think you do see that. Yeah, absolutely. The first week or two of the college, it's so quiet you can hear a pin drop. And by the end of it, you can't get them to be quiet. But the first week, they're like you said, they're writing everything down that you say. I like that. And I also found when I taught at the high school, Microsoft was nice enough to donate about 20 controllers. And so I introduced XNA gaming. So again, it's project-based, but it was also something that they were doing at home. And so if they could write their own programs that would allow them to use the controller, like that was such a great connection. And then I was able to expand on that. So any way you can find a connection to what they enjoy in life. This summer, I'm doing a camp on how to add a mod to Minecraft, and we're going to try and teach a little bit of Java using Minecraft. And if you can do something like that, I think you really pique their interest, and then you can get over that hump that this is something that I can't do. Now they feel like I can do it.
Well, I mean, that's basic teaching pedagogy. You find something. Actually, okay, so I'm a Jesuit, and what we would say is you go in their door and you come out yours. So you use whatever it is that they're interested to teach them the things that maybe they wouldn't want to learn otherwise. And I'll give an example that a lot of people hate because they hate that I continue to cover these. But I've gotten really big into quadcopters because, well, I enjoy designing them. I enjoy building them. There's a lot of people who say, well, they're just toys. But there's so much engineering and math that goes into making these things. And people are learning about aerodynamics. They're learning about microcontrollers. They're learning about logic trees to keep quadcopters in the air. And it's that sort of stuff. It's that kind of project-based knowledge that I find so effective. I want to extend on your comments about that project-based knowledge. We have someone in the chat room who was just saying, oh, build a Minecraft module. And they were joking, but again, yeah, that's what you do, right? I mean, you find something that they'd want to create, and like it or not, they're going to learn something when they try to create it.
Exactly. Yeah. That's it. I mean, we're going to show them how to create their own swords, how to create their own pickaxes, how to add colors and add ore. And I don't even know it all yet, but yeah, I think because we're going to try and I love what you just said, Father, is that, go in their door and come out ours. I'm going to remember that one, but that's what I'm trying to do. And I find that a lot of times that's my highest success is when I can make that connection with the student. Yeah.
I do want to move on to something else that I saw in your biography when I asked Linda. I said, look, can we have her contact information? I really want to get her on the show. And that is your involvement in STEM.
Yes.
For the people at home who maybe have been under a rock and they have not heard STEM, what is STEM?
STEM, or some people like to say STEAM, you know.
That's right. That's right.
Yeah, so STEM is is an acronym, which means that you take the first letter of each word. It stands for science, technology, engineering, either arts, and mathematics. And those are 4 fields that have historically been male dominated. And so those 4 fields, and they're also the 4 fields that really are the future of a lot of our students. We need to encourage kids to go into those fields, and especially young girls, which is another passion of mine, is trying to get more females, sorry, Father, interested in these topics by showing them that they're not male-centric, that they are problem-solving, because I think a lot of girls and women like to solve problems, and that they are attainable. You can program, you can build, you can be an engineer, you can be a scientist. So STEM is a key word for the future, I think.
Let's talk a little bit about this, especially since we've got both you and we've got Lou, who's working in a professional environment with programmers right now. When I was growing up, I just thought, okay, well, there's just a bunch of guys here. In fact, my computer science class of students, a freshman at Santa Clara University, I think we had 3 women in a class of about 60 of us. And I actually think that was a decent ratio for what we normally got.
Right.
Lou, you're a project lead. You are a project manager. You assign programmers work. I don't want to put you on the hot seat, so don't answer if this is going to get you into trouble. But how many female programmers do you have?
On my team directly, I have 1, but out of 23. But there are in the entire group. There's actually quite a bit. There's more and more each year. We get more and more from different teams. And again, I work in a business software division, so from college graduates, it's not the most lustery type of work to do, but it's kind of like Peggy said, it's one of those growing areas, and we tend to get a lot more going each year.
Well, Peggy, how did we get here? How do we get to a point where we have to actively go out and say, hey, you know what, this engineering stuff, this math stuff, this science stuff, yeah, it's not gender-based.
Right, yeah. How did we get here? That's a pretty interesting question, Father. I'm not sure. I think a lot of it kind of goes back to even the fact that up until maybe like 40 years ago, maybe even less, most women got married and stayed at home to begin with. I know growing up in my household, my mother was a stay-at-home mother and as a role model, but I don't know why I didn't follow her foot. I think probably my desire to learn more about math is what kind of pushed me in the direction. But I was definitely one of the odd number out. I was definitely one of the few people that liked math as a girl. Yeah, I wish I knew, Padre. I really don't. I think there's just still this conception that math is a more that I should say. What I should say is that boys find math easier than girls, which I don't think that's true. But I think there's still that that misconception out there. And I don't know that we've gone back to figure out if that is truly the case, or is it the way that it's being taught? Do we need to change the way we teach math to make it more project-based? And I think they've made some changes over the years. But, Father, I just don't know. All I know is I keep trying to work on trying to overcome it. That's for sure.
No, and I remember you actually had an interview on, I think it was PBS NewsHour.
Yes.
And one of the things that you said that it got clipped and it's used as a soundbite is you strongly believe that every student at some point in their high school or college career needs to take a computer programming class. And I think that's actually a huge step in trying to fill this gender gap, which is get the women who otherwise wouldn't even think about this as a career to have to take one of these courses, and then get them to realize, oh, I'm good at this. Well, I have a brain for math. I have a brain for programming.
Father, I don't mean to interrupt you, but I just have to share that, like, when I teach the Intro to Application Programming with Java at the Penn State University, so this is my third year now. I can't tell you how many girls have come up to me, and one either said, "I'm changing to a more computer science major, a design and development kind of field," or "Thank you so much for introducing me to this. I love it. I think it is so much fun." And again, I think it's that paradigm that it's hard, but I just love watching their faces light up. And some of the boys do too, but the girls are very vocal about it, coming to me and saying, "I had no idea. This is so much fun. Like, wow, this is so cool to watch it, to kind of program it and watch it work. It's like, wow, that's awesome." So I think what you said is right. We just need to, and I still stand by what I said. I think every student, preferably either junior high, should take at least one programming course, get exposed to logical thinking and how to break a problem into steps. I mean, that's life, right? We are encountering problems every day, and the tools to be able to solve a big problem, if you learn how to do it in pieces the way you need to do it for programming, that goes a long way in life.
Let me go ahead and get Lou into this conversation. Lou, again, I'm going to draw on your experience as a project manager. When you are looking at candidates for your projects, I know that you previously told us that you're always looking at their logic skills. You're looking at, exactly as Peggy mentioned, can they break down a complex problem into its constituent parts? How important is that when you decide which programmers go into which projects?
Really important. I mean, the design of an application can mean, at some point, if you design it for only a specific bunch of scenarios and then you move forward, you'll find out later on there's a maintenance nightmare and you have to go back and redo a bunch of components, and it can cost a lot of money to do that. So there's a lot of times when if you give a project to a person that doesn't understand how to break apart into small pieces and then build those pieces, then you'll find out that later on you'll get in a much world of hurt. So I think it's super important to have somebody really understand those.
All right. Peggy, I want to ask you one last question before we start to move over to your advice for the future generation of programmers. And it has to do with, again, with that suggestion that everyone take that computer course, that one single computer course, that hopefully the idea is it leads to more and more and more.
Oh, absolutely, yeah.
But again, one of the themes that has been recurring in these wildcard episodes are our programming gurus telling us that we live in a generation right now where people have basically abandoned foundational knowledge. They may know how to use a lot of apps on their smartphone. They have no idea, nor do they have the desire to know how they actually work, how they're programmed, what they interact with. The STEM discipline, the STEM push, it sounds to me, at least in part, that it's to reconnect people with that foundational knowledge.
Yeah, I think you just got it, Father. It is. I think the STEM push, and again, I think I agree that currently students have very peripheral knowledge of those things. But if you take those same students and you actually sit them down and say, "Here, follow these steps," and what you're going to have when you're done is your own app that you made that you can now make open source and available to everybody to download onto their phones. I think if we can show the value in that, I think, and this is just my perspective, that you'd see a lot more students taking the foundations a lot more seriously. It's a tough one, but I think if they were exposed to it, I think they'd really, like you said, the more people that try it, I think that at least out of some of those, you're definitely going to get students that want to continue on and take more advanced courses.
We're speaking with Peggy Fisher, programmer extraordinaire, guru, proponent for STEM, and perhaps one of the coolest code warriors that we've had on the show. We're going to get back to her. She's actually going to expose some of her secrets for the programming code warriors of the future. But before we do that, let's go ahead and thank the second sponsor of this episode of Coding 101. Now, folks, let me ask you something. If you're watching Coding 101, or if you're helping in our forums, which, by the way, thank you very much. It's great having you in there. What do you do once you've finished your app or once you've finished your service? How do you stand it up? Well, in the old days, what you'd have to do is you'd actually have to build a server, build iron, set it up the proper way, get your services running, and then start testing it. Or maybe if you had a little bit of cash, you could rent a server or part of a server somewhere in a data center, somewhere in a colo. But you don't have to do that anymore. We don't live in that generation where you have to buy bare steel, because we've got companies like DigitalOcean. Well, DigitalOcean is a place where you can go if you want to stand up your projects immediately, get them exposed in a sandbox, or put them out on the internet so that people can actually use what you've created. Whether you're an experienced code warrior or just getting started, you need their flexible, reliable, and affordable hosting. DigitalOcean provides developers with droplets. These are virtual private servers that can be customized and deployed quickly to host websites, web apps, production applications, personal projects, virtual desktops, and almost anything else you can think of with full root access. Think about that. You don't have to worry about some admin granting you the wrong permissions. You control your applet. You control your world. Now, DigitalOcean is built for developers, and it's used by over 400,000 of them, including us here at the Twit Brickhouse. You can deploy and configure your droplets via a streamlined control panel or a simple API, and you get to choose your OS. You want to run Ubuntu, CentOS, Debian, Fedora, CoreOS, FreeBSD, they're all available. They have a one-click install that allows you to quickly deploy apps like Django, Docker, Drupal, LAMP, GitLab, MediaWiki, Node.js, WordPress, Ghost, Magneto, OwnCloud, Ruby on Rails, and more. And all their servers are built on hex core machines with dedicated ECC RAM and RAID SSD storage. This isn't going to be one of these outfits where you buy time and then 50% of the time it doesn't actually deliver because it's over congested, it's too slow, it doesn't have the resources. Now, they're also highly scalable to meet the demands of a rapidly growing application or business. You can start small and then you can scale up. Their servers can have up to 20 CPUs, 64 gigabytes of memory, and 640 gigabytes of SSD hard drive space. They also have auto backups and snapshots that let you easily clone, deploy, and resize your droplets as you go, which means you can start small, and then as your business grows, as the demand increases, you can increase it with a single click of the control panel. They give you full-feature DNS management and easy-to-manage domains with dedicated IPs. They give you web console access with HTML5 plus SSH, SFTP, and KVM VNC for virtual desktops. They have an active community, which, if you are a geek, you know this is one of the best ways to come up with new ideas or to solve solutions. People who are actually using the service who can tell you what they did to fix the problem that you're having right now. It's so easy to get started. You could get up and running in less than 55 seconds. Go ahead and deploy your own cloud, your own SSD server with DigitalOcean. They have incredibly affordable and straightforward pricing. Servers start at only $5 a month. There's also hourly pricing available if you just want to stand something up to test it. You could start at less than a penny per hour. But we're going to make it so that you get started today and start deploying an SSD cloud server for free. Visit DigitalOcean.com and create an account. Once you confirm your email and account information, go to the billing section and enter the promo code C101 for a free $10 credit. That's plenty to get started, and you can explore what DigitalOcean can do for you. That's DigitalOcean.com. And once you sign up, enter the code C101 in the billing section for a $10 credit. And we thank DigitalOcean for their support of Coding 101. Peggy, back to you. So we've established your bona fides. 30 plus years either programming, directing IT, or teaching. So obviously, you've got a little bit of knowledge here that you could share with us. And you shared it in your lynda.com courses. But let's start with the most basic question. What would you say to someone who is just looking at getting started in programming? What's the right way to approach it and what's the wrong way to approach it?
Oh, good question. The right way, I believe, to approach it is to leave all your fears at the door. Go in saying, I can do this. I know I can, and if I need help, I'll find it. I'll network. I'll do what I need to do. I think that's really important that you believe in yourself.
Yeah, and that's actually it's interesting because. I don't want to put a downer on the whole episode, although I am about to do it right now. But if you do coding professionally, there are going to be some dark days. There really are going to be. Lou is shaking your head. Lou, Lou, tell me a little bit about these dark days, because these projects can go on forever, and it can always feel like everything that you've done is getting torn down in the next revision as they add requirements. Tell me a little bit about what a programmer would have to put up with, what they have to be ready to put up with if they want this as a career.
You have to have a thick skin when it comes to, because when you design something, you know, sometimes you don't necessarily, again, like I said, think of all scenarios. So when you push it forward, somebody's going to take it and say, wow, you know, this doesn't work for this scenario. So I need to go and add a whole bunch of things to it, maybe rework it, refactor it, and redo it. And so you have to have a thick skin just to know. You know, you have to have you want to learn. You have to have an inkling for learning too, to say, oh wow, you know what, I didn't think about that. You know, and then the next project, the next time, you then have the opportunity to add that part of the thinking process to it. So, you know, that it's really, again, like she said, it's a learning process, and as you grow and as you get experienced in it, it makes you better. And I think that was one of the questions I even had for Peggy is, you know, it's all believing in yourself, but do you think it's more of a repetitive thing too? Does it make maybe doing it over and over again to kind of get that muscle memory going? Does that normally help your students kind of do better and learn better at programming?
Right.
Oh, absolutely. We talked earlier about pedagogy and approach, and you know, I could stand in the podium and talk the whole 50 minutes, but if I don't have them do it over and over again and do it in class and do it for homework, it just isn't going to stick, especially if it's new to them. So, you know, I think it is repetitive, and there are days where you're going to look at something and you're not going to be able to figure it out. You know, you're going to look at it and look at it and look at it, and sometimes you just need to walk away for a little bit, you know. Or and one other thing, Lou, I think you said, which I thought was great, is that the thick skin, as well as the ability to say, yeah, I'm fallible. I might have missed a test case. I might have missed something, and that's okay. That's why I handed it off to you, so that you can find anything that I missed, because maybe I had some blinders on. And that's really important too, is to talk about testing. I don't know that we emphasize that enough in the short time frame that I have the students, but in the real world, Lou, like you're in, testing is a critical part of any application development process.
Let's talk a little bit about that, because now you're talking about your baby. When you create something, it's your baby. It's your heart, your soul. You've put a little bit of your ego into this, because every time you present code to the repository, to the overall group that's going to approve it or disapprove it, you're putting a little bit of yourself out there. And you know, there's this axiom for writers that when you hire an editor, your editor's job is to kill your baby.
Right.
The editor's job is to take something that you would never remove because you remember how hard it was to create it, and they'd say, this is uninteresting, get rid of it.
Right.
Except if you're a programmer, you have to kill your baby. Your group comes to you and says, your code's not good. It's not elegant. It's too resource intensive. You got to change it. How do you do that after you've put the hours and hours into it? How do you go back and step away and then come back in with that fresh look and say, I know I just created this, I'm going to tear it apart now?
You know, I think you need to look at that as a learning experience, and you need to say to yourself that hey, it's okay, you know, and I can do this again. And once you get started again, you find yourself right back in where you wanted to be. You're right back in having fun again. But you're right, Father, that there is going to be a little bit of time there where you're crushed. You know, you're just like, oh, I thought I had that one wrapped. I thought it was done. I thought it was down the pike, and now it's back in my lap again. But I think you just need to take it and say, okay, it was a learning experience, and you have to, you can't take it personally, although I know you probably do, but like Lou said too, just keep working at it, working at it, and working at it. It's
that thick skin. You got to have the thick skin, and even if you're taking it personally, you can't look like you're taking it personally.
Right.
That's how it works. Here, another basic question that we get all the time, and that is people who come to us, and maybe they're at that first step. They want to see. They want to peek under the curtain, see what's going on, see if maybe they have that natural talent, that natural passion for programming, for computer science. And they say, what language do I start with? And I find this so difficult to answer, because I will always want to answer with, well, of course, it's a language I'm familiar with. That's what you should learn. Or the one I love. That's what you should learn. How do you answer it?
Yeah, or basic, or Father, I think I would have to first have a follow-up with them and say, what is your end goal? Are you interested in more of a business kind of programming language? Or are you interested in more of a computer science kind of programming language? And so if they're interested in maybe writing maybe something for their phone, maybe they are interested in writing a phone app, then maybe we might want to say, why don't you try Ruby on Rails? Or I agree with you. It's very difficult, and there's a few that I absolutely love. Like I love C#, I love Java, but they're definitely not for everybody. But I think some of the languages are more, I think, aligned with business versus engineering. And so if you could figure out those two, so maybe a C++ is good for someone who wants to go into computer engineering, might want to look under the hood into computer engineering, whereas a maybe even a C# or a Java or even although I don't think too many people use Visual Basic anymore, but even a Visual Basic or something like that might be good for someone who wants to have a nice little front end to something, or maybe HTML and CSS if they're more interested in web design.
I like that. I like that, defining your goal and then then applying the language afterwards. I think you're right. I think that works great for any type of project, and that'll help you learn, because then you're kind of reaching or working towards a goal. So I think that helps a lot. Peggy, what kind of resources, when students come to you and they say, hey, I have this goal or have this project idea, or even some of the projects you give out, what other resources, other than obviously the curriculum and the books that you give out, do you recommend to people to kind of go out and learn these things?
Well, lynda.com, because I just think
Of course, right?
But I really do. The only reason I even got involved with Lynda was just because I think that the resources that are available there are so numerous and really wonderful. But almost any kind of, if the person is more of a, likes to listen and stop, the video series on, there's a lot of sites, I'm sure, that have little video type of series similar to Lynda, but that I think is really nice because it's very self-paced. You can stop. They have challenges. So I think as long as it is something that can supplement what I'm trying to teach them in class, I've done videos on my own on YouTube, or maybe I've found videos that other people have done on maybe even Khan Academy if they're trying to do some math, associated with the project. But it's interesting, and I would love to hear both of your perspectives too. One of the things that I talk about a lot now is the way that we communicate with our digital natives. My son is going to be 13 in June, and if we want to find him, we know where to go: in front of the computer watching YouTube. So, and I don't think he's much different than any other 12, 13-year-old. So how can we take advantage of that to get to these kids and provide them in a medium that they're used to? So I guess to supplement it, I say video training is great. Textbooks, I'm more of a hands-on textbook kind of person. I really like that as a backup to my learning.
Peggy, one of the other interests that you have that I'd love to talk about here, and it goes hand in hand with, what do you do for digital natives, is in the last, probably 5 or 6 years, really, we've seen the emergence of this weird new part CS, part EE. It's part computer science, part electrical engineering, in microcontrollers that are very readily programmable, that are easy to understand, that give digital natives something that they can program, and yet they see its effect in the real world.
Right.
I know you're interested. You are involved with Arduino programming. I know you're involved with Lego Mindstorm. Mm-hmm. Has that been a good entree for digital natives for you?
Oh, absolutely. Both of them exhibit the hands-on feature that I think is wonderful, that maybe you don't get with a Java or a C++. But the Arduino, the IDE that we use for Arduino, is very similar to to C++ and Java as far as the syntax goes. But yet you see a light come on when your program works. You see the wheels move if you attach it to a little robot. The Lego Mindstorms, is just, I think, a fantastic way to not only teach about programming, because you do program the brain of it, but also engineering. They have to figure out, how do I put these motors on so that when I'm done building, that when I program it, how do I tell one motor to go forward, one to go backward, because they're on in opposite directions to have it move forward. So there's a lot of really great learning opportunities. I try and introduce a lot of math with the Lego too. If I want to figure out how far the robot's going to go, well, I explain to them, well, what's the circumference of the wheel? That's one rotation. Well, how can you figure out what that distance is? So there's a lot of numerous possibilities there. And you mentioned logic gates earlier too, and the Arduino is great for that. If I'm getting a digital signal coming in on one of my pins, and you can even have a little branch. I think it'd be really cool to have a little branch off and talk more about electronics and give the kids a little understanding about how do the lights come on? How do things work? And that's kind of, I like that it kind of ties in other STEM fields that if you wanted to, you could branch off and talk more about those. But I think they're both great, great tools for teaching. And I find that I get a lot more, the students are a lot more attentive when I'm using those types of tools.
So Peggy, this type of work, even, programming with microcontrollers and even learning languages, it can be intimidating sometimes. And people, even based off of your surroundings, when you're in a class, maybe somebody gets it better than the next. What do you kind of encourage your students? How do you get those students that are afraid to basically ask the stupid question? Like, how do you get them beyond that so that they can start, growing and learning from, not only the people next to them, but, from, being able to ask that question when they're lost?
Yeah, and that's a good point too. So some of the techniques that I use in class is really kind of simple. Like, I'll use a random selector to randomly have them work together on a project, and it's kind of amazing how, like you said, so you have one person who normally is very quiet. Randomly, if they end up with somebody else, they have to talk to each other. Or sometimes it does take the teacher to give a little prodding as well. So I think you need to be a teacher that moves around and listens and talks. But once you get those quiet students that are maybe a little intimidated, even if you have to sit down and do a little one-on-one with them, that once they get past that hurdle, I usually find that they open up and they start to take more chances.
We've been speaking with Peggy Fisher, a lecturer at Pennsylvania State University, a faculty member at lynda.com, our favorite source for knowledge, and an all-around uber geek. Peggy, we thank you so very much for joining us here on Coding 101. We are going to invite you back to be a code warrior. It will be the language of your choice, any language you want to teach, but what we would love for you to come back and be a code warrior for us. Would you do that?
Oh, Father, I'd be honored. And this has been so much fun for me, too. Thank you. Well, I would really like that. Yeah.
Believe me, I've been watching the chat room. They love you. You're exactly the kind of guest that we want to have on this show, because you show the passion for computer science, the passion for programming, and hopefully that rubs off on people. Peggy, if you could please tell people where they can find you on the internet. So we already know that they can find you at Pennsylvania State University. We know that we can find your courses out on lynda.com.
Yes.
If they wanted to find out more about, say, your work with STEM, where can they go?
Padre, probably the best place would be to Penn State University. We offer a iTech Academy summer camps, and there's a lot of information out there. I work for the College of IST. So if you just search Penn State College of IST and my name, you can probably see a lot of the work that I've done with the camps. And the camps are really all STEM related. They're like this summer I have a middle school girls camp coming up, and a middle school boys camp that's going to be modding for Minecraft, and then high school Minecraft and high school Lego Mindstorms. That's also a lot of times we put pictures out there and they can see more information there. So that's probably the best place to go right now.
We salute you, and we will see you back here on Coding 101. Again, it's such a pleasure.
Thank you, Father. You too. It was nice talking to you too, Lou.
You too. Thank you. Take care.
Yeah, you guys are awesome. This is so much fun.
It is fun. This is what we want to do, right? I mean, Coding 101 is all about having fun, really, honestly. And if you enjoy this, you're probably going to enjoy programming.
Yep, I agree.
Of course.
Don't forget to be a lifelong learner.
That's right. I couldn't do this show without Lou. Lou Maresca, could you please tell the folks at home where they can find you?
Absolutely. Always find me on Twitter at LouMM. And of course, all my work from Microsoft is at crm.dynamics.com.
Well, folks, that's all the time we have for this episode of Coding 101. I do want to remind you, though, that if you want to see our back episodes, maybe if you want to download some of our previous modules so you can start diving into the wonderful world of the programmer, you can always go to our show page at twit.tv/C101 or Coding 101. It all goes to the same place. There you will find not just all of our episodes and all of our show notes, but also a drop-down menu so you can automatically get our episodes in the format you want into your device of choice. Do you want the audio version into your phone, your Android or iOS phone, so you can listen to us in the car? You could do that. Do you want the video version on your tablet so you can watch us at work? You could do that. Do you want the high-definition version on your laptop, your desktop, your Mac, your PC, so you could watch us when you get home? You could do that. Again, that's twit.tv/coding101. Also, did you know that we actually have a Google Plus group? If you just go to Google Plus and look for Coding 101, you'll find us. Join us, and you'll be able to find people who can help you in your quest for coding nirvana. We've got beginners, intermediate, and expert programmers in there, and it's a great place just to congregate and find out what's going on. Finally, don't forget that you can follow me on Twitter. Just go to twitter.com/PadreSJ. That's at PadreSJ. There you'll find my particular brand of snark, as well as what I'm doing here on the Twit TV network. I'll tell you about the guests we're going to be having, the topics we'll be covering, and the projects that we'll be doing. It's all part of the experiment that is Twit TV. Now, I know there has been some concern about what's happening with the Twit TV stream, but let me tell you that you can still find us mostly live here on Mondays at 2:30 p.m. Pacific time, and you can join us in the chat room in whatever form it may take at live.twit.tv. I want to thank everyone who made this show possible, of course, to Lisa and to Leo for letting us do Coding 101, to my fantastic TD/engineer, Eskimo Zach. Zach, I don't know if you have a camera on yourself, but if you do, could you please tell the folks where they can find you?
No room for a camera in the TriCaster. Guess you're going to have to stare at my Twitter page. You can find me at Twitter at EskimoZach, spelled with an H. Thanks.
Thank you very much for joining us. I'm Father Robert Ballecer, the Digital Jesuit. This has been Coding 101. End of line.